Gradle 8.0 contains some exciting updates. Here's an overview of the major changes. For more details, check out the longer format video linked in the description below.
We need a number of improvements to the Kotlin DSL in Gradle 8.0. The first one is improved script compilation performance. In this release, we introduced an interpreter that avoids calling the Kotlin compiler for the plugins block, and it provides an overall script compilation time improvement of 20%. In this release, it supports a part of the constrained syntax of the plugins block, and that's simple plugin request with just an ID or an ID and a version and or apply false and the Kotlin shortcut. When the interpreter encounters plugin spec accessors like you can see here for the Acme plugin or version catalog aliases, it will fall back to the Kotlin compiler. We will add support for this too in future Gradle releases. We upgraded the embedded Kotlin to Kotlin 1.8, and so we were able to update the Kotlin DSL API level and language level for Kotlin to 1.8. So with Gradle 8, you get all the improvements that were made to the Kotlin language and standard library. And it also means that you can use libraries that leverage Kotlin language 1.8 in your build logic now. We made the script compilation use the JVM you use to run Gradle as the target. Before we were fixing this to Java 8, and so now you can use libraries that leverage more recent Java versions. So this is about the standalone scripts, like the setting scripts, init scripts, and the build script. And the next one is about pre-compiled script plugins. So that's the ones that you would ship to the plugin portal, for example, as binary plugins, or that you would have in your build logic, build source, or included build.
Gradle provides two different ways that you can use to implement plugins and tasks that can be used within your build. The first of those is the build source directory, and the second is using an included build. In Gradle 8, we've taken features that included builds have had for a long time and made them available for build source. So the build source now becomes basically an implicit included build. So the first of these changes is that Gradle does not automatically run the build source tests unless they've been explicitly requested. So this can save a lot of time for developers who are just working on the software and not interested in changing the build source implementation. Here I've got a build with a build source directory. It contains a plugin implementation and a bunch of tests that are quite slow. Let's run this with Gradle 7.6. So you can see here Gradle is running the tests and they're quite slow. And then it goes and builds the project. Let's try the same thing with Gradle 8. So you can see here it skipped the tests, it's just built the jar, which is all it needs to do. So it's a lot quicker. So what if I actually want to run the tests? Well, Gradle now allows you to run build source tasks from the command line and from the IDE. So with Gradle 8, I can just list the tasks on the command line, just like any other task, and Gradle will run them. So you can see it's running the tests. So Gradle now applies init scripts to build source build, just like it does for included builds. So this can be useful if you have an init script that you use to inject configuration into your build. So let's run the build with Gradle 7.6 and apply an init script. It's running the tests again. So you can see the init script has been applied only to the main build. So if you want to inject configuration into build source, this isn't going to work. So let's try the same thing with Gradle 8. So you can see here the init script has been applied to both the main build and to build source. Finally, build source can now include other builds. So this is useful if you have some shared convention plugin that you want to apply to your main build and also to build source. have another build. It has a build source directory, but it also has an included build with a shared plugin. Let's take a look at the settings script for build source. So you can see it includes the settings plugin build and then applies the settings plugin. Let's try running this with Gradle 7.6. So you can see it blows up saying that you can't include builds in build source. Let's try running this with Gradle 8. So you can see here it's built the shared settings plugin, it's applied it to build source, it's built build source, and then applied the shared plugin to the root build. Gradle 8 includes some performance improvements for configuration caching. In previous versions of Gradle, tasks would run automatically when configuration caching was enabled, only if Gradle could reuse the configuration cache entry, so when there was a cache hit. However, when there was a cache miss and Gradle needed to recreate the configuration cache entry, it would not run the tasks in parallel. So now in Gradle 8, Gradle will always run tasks automatically in parallel when configuration caching is enabled. And this includes for cache hit builds and also cache miss builds. So this happens regardless of whether you use the -- parallel option, and this behavior will eventually replace -- parallel. Here we have a build with configuration caching enabled, and the build defines a number of tasks that take some time to run. So let's try this out with Gradle 7.6. So here we get a cache miss, and you see Gradle's running these tasks sequentially rather than concurrently. Let's run that again now and see what happens when we get a cache hit. So you see now Gradle 7.6 is running those in parallel. Let's try this out with Gradle 8 now. You see Gradle gets a cache miss, but it still runs those tasks in parallel, and it's a lot faster. We run this build again, and we get a cache hit, and the tasks run in parallel. This change also makes it easier when you are working on migrating your build to be configuration cache compatible. Gradle can now detect deserialization problems in cache miss builds, whereas in previous versions, you could only do this for cache hit builds. So what that meant in practice is that after you made a change, you needed to run the build twice to be sure that you've seen all the configuration cache problems. And now you only need to run the build once. So this is a big improvement for feedback time. So here we have a task implemented in dynamic Groovy that accesses the project state at execution time. Now this isn't allowed when configuration caching is enabled. So let's see what happens when we run this with Gradle 7.6. So we get a cache miss and Gradle says build successful, everything's okay. However, let's run that again and get a cache hit this time. We can see that the build blows up because of the problem in the task. Let's try the same thing with Gradle 8. So you can see here Gradle gets a cache miss. However, it also reports the problem from execution time. Finally, this change also means that Gradle can release all of the heap that it uses at configuration time before it starts running tasks. And this can really reduce the maximum amount of heap that Gradle requires to run your build. Here we have a build that allocates a large amount of heap at configuration time, and then also has a task that allocates a large amount of heap at execution time. Let's try this with Gradle 7.6. And you can see the cache miss build blows up. Let's try this again with Gradle 8. So you can see here, again, we get a cache miss. However, the build succeeds because Gradle is able to release all of the heap space that's allocated at configuration time before the task goes and allocates a huge amount of heap at execution time.
So the first thing that we did here is that with the CodeNarc plugin now detects the Groovy runtime version. So the idea is that if you're just using the default CodeNarc version, it will detect whether the runtime version of Groovy is 3.x, and if so, it'll use the 3.1.0 version. If it's 4.x or above, it will now use the 3.1.0 Groovy 4.0 variant, and you won't have to worry about this. This is only applies to default, of course, and so if you're using the tool version setting to configure your own version, you can still do that, and it doesn't have any effect on that. And then the other thing that we did with code quality is we made some improvements to the PMD task. And so whether you're using configuration cache or not, PMD tasks will now run in parallel or execute in parallel by default. So you could potentially have multiple code quality checks that are running at the same time on the same project, and those will execute in parallel now. The other aspect of this is that PMD now runs in a daemon process. So it runs out of process. Previously, it ran in the build process itself. Now it runs in its own daemon. And one of the benefits of this is that it will detect the Java toolchain that you have configured. So it'll automatically align the PMD process with the version of Java that you're using for compilation and testing and the such. So it's one more stumbling block that you wouldn't have to worry about now, because all of those things are aligned, as opposed to, previously, if the build tool process was maybe running in a different JDK version or Java version, you could potentially have conflicts there. So since Gradle 4.x, Gradle automatically cleans the caches in the Gradle user home directory. What this does is previously it would use a fixed threshold for inactivity. So it's either 30 or 7 days, depending on which cache it is. And what that means is that, for instance, if a particular cache entry had not been used for over 30 days, it would be eligible for cleanup when the cache cleanup executed. And so these are now configurable. To configure them, what you would do is create an init script and put it in that Gradle user home directory under the initd directory. And in that script, you can set these thresholds. The other thing here is around the frequency of cleanup. Previously, you could disable cache cleanup by setting a property in your Gradle user home, Gradle.properties. Now you can also set it via the DSL as well. And again, this would be in your initd directory in an init script. You would configure this cleanup equals cleanup.disabled.
The toolchain download repositories, which were developed and introduced in 7.6, become the only choice to configure toolchain auto-provisioning in 8. This happened via removing the Adoptium and Adopt-OpenJDK downloaders, which were the legacies at this point. To replace them, we have developed a new toolchain resolver called the Fuji resolver.
And another small thing is that it's a bit easier to export trusted keys for dependency verification. Before Gradle 8, it was only possible to export keys when updating the verification metadata file. This is sometimes a bit annoying because it's very easy to forget this additional -- export keys. But now if you can just run it as a separate command.
One more item for dependency verification. It's now mandatory to use full key fingerprint in your dependency verification metadata for any trust entry. That's done in order to make sure that you're not opening up yourself for collision attacks. So that means that it's for the trusted. If you ignore keys, then you can still use short forms of short IDs or long IDs, because then the only risk you carry is that you effectively exclude more keys than you wanted.